we discuss about optical instruments. In optical instruments, mainly we have to see the microscope, the compound microscope and the telescope. See, in microscope, there are two types. That means the final image is at a least distance of distinct vision, and the other one, the final image is at a infinity. We will see the formula of both the cases in detail. The first case, the simple microscope, the final image is at a least distance of distinct vision. Say from O to A dash, the distance is capital D, that is the least distance of distinct vision. Here the object is placed between focus and the optic center. The ray diagram, how to make, you all know it. The ray parallel to the principal axis after refraction passing through the focus, then other one it is passing through the optic center. When you extend it back, the image is formed here. So this distance is the least distance of distinct vision of our eye. Now you know the formula, 1 by f is equal to 1 by v minus 1 by u. Multiply this equation by v. So you will get v by f is equal to 1 minus v by u. V by u, that is the magnification, that is the image distance upon the object distance. That is v by u is equal to 1 minus v by f. Then we will put the value of v here, that is v is equal to minus d. According to sign convention, you know that the measured distance will be v, that is minus d only, because the distance measured is opposite to the direction of the incident ray. Now put the value and we got the answer. Magnification m is equal to 1 plus d by f. Next we have to consider the final image is at infinity. Here the object is placed at f. So the final image is at infinity. Here we cannot measure the height of the image. So we will consider the angle subtended by the image at the eye, that is theta I, and the angle subtended by the object at the eye. Here we kept the object at f, but here you can see that I wrote here d. Why? Because the object is placed at least the least distance of distinct vision, d is equal to 25 centimeter. Then only it is visible to us. And what is angular magnification? Angular magnification is the ratio of the angle subtended by the image to the angle subtended by the object. From the diagram, see what is theta I. Here the height of the image and the height of the object both are parallel, and that means they will subtend the same angle here. So I measured theta I in terms of h only, that is theta I is equal to h by f. Then theta O is equal to h by d. Then magnification m is equal to theta I upon theta O, that is h by f upon h by d, that is equal to d by f. Next topic is compound microscope. In compound microscope, there are mainly two lenses. One is the objective lens and the other one is the eyepiece. Objective lens, that means it faces the object, and the eyepiece, it is near to the eye. The focal length of the objective lens is less than that of eyepiece, and the diameter of the objective lens is also less than the eyepiece. Here, focal length of the objective lens we took f4, and the focal length of eyepiece we took fe. Now, how the ray diagram drawn? Here the object is placed between f4 and 2f4. That means f and 2f of the objective lens. Then the image is made beyond 2f of the objective lens, that is this one. The height I expressed as h. This image acts as the object for the eyepiece. That means the focal length of the eyepiece is more than the objective lens. So this image acts as the object, and this object is between FE and O. The final image is at least distance of distinct vision. The angle subtended by the final image, that is theta I. The angle subtended by the object, that is theta O. See here, this height and this one both are parallel. These two are parallel, that is why this angle I took, this is theta O. Now see, angular magnification you know, that is m is equal to theta I upon theta O. Then theta I means what is theta I? That is hi. This is hi divided by the distance between this and this one, that is x. That is hi by x. The same way theta O, that is the height ho divided by x, that is ho by x, that is hi by ho. Here I wrote hi by h into h by ho. No change is there, the same only. Then what we did here multiplied and divided by h only. Here see, m is equal to hi by h into h by ho. What is hi by h? Hi is the height of the image produced by the eyepiece. H is the height of the object for eyepiece. That means hi by h is the magnification produced by eyepiece. The same way, h is the height of the image for objective, and ho is the height of the object for objective. So h by ho, that is the magnification produced by objective. So we can write m is equal to magnification produced by eyepiece into magnification produced by objective, that is mo into me. Now we know that mo, that is the magnification produced by the objective lens. For that the image distance is VO and the object distance is UO. So magnification for objective lens is VO by UO. And then for eyepiece, for the eyepiece alone, if you consider, the final image is at a least distance of distinct vision. This is the first case of simple microscope, already we discussed. So this formula we derived there, we will put that formula here, that is 1 plus d by Fe. Fe is the focal length of eyepiece. Now the formula is magnification m is equal to VO by UO into 1 plus d by Fe. You have to consider if the final image is formed at infinity. In that case, the image by objective is formed at the focus of eyepiece. When the object is at the focus, then the final image is at infinity. That formula also we already derived for simple microscope. We put the value here, so it is coming d by Fa. Then what is L and Fo? Here the object we will keep very close to the focus of the objective lens. That means you can consider UO is equal to Fo. Then the image will be very near to the eyepiece, that is the distance between objective and eyepiece, that is the length of the tube. So we consider VO, that is the image distance from the objective lens is nearly equal to L. So we put the value here, that is L by Fo into d by Fa.